All right, welcome to our next video on programming in Java. This is the video for the second checkpoint of Enigma, which is for the Advanced Caesar Cipher, was what we've called it, the Advanced Caesar Cipher. We saw in checkpoint 1 that a regular Caesar cipher meant taking a message that we wanted to encrypt, a message like hello world, and shifting every letter up the alphabet 1. So an H became an I, an E became an F, both L's became M's. We called it a basic Caesar cipher when everything went up by 1. Well, what if we wanted to move something up by more than 1? What if we wanted to move it up by 3 or move it up by 7? How would that work? So what I've got here is an example of a letter map when A, rather than getting shifted to B, which would be a shift of 1, it's getting shifted to E. So A, B, C, D, E, I believe that's a shift of 4. Couple of notes, we still wrap the alphabet, which means that if we're up at the top of the alphabet and we have a number big enough to go past Z, we return down to A. If we are decrypting lower in the alphabet and we're counting down and we go past A, we end up back up at Z. So we do still wrap the alphabet. We got to be able to handle spaces, just like we did for checkpoint 1. So if I decrypt by a shift of 7, A space YLE, that's going to become T Rex, because starting with A, if I count back from A 7 spaces, I should get all the way back to a T. So what does it look like if we enter these commands in? I can show you. If I say encrypt with a basic, I guess this is an advanced, by 3 steps soup, it becomes VRXS, the S becomes a V, the O becomes an R, and so on and so forth. If I say decrypt AYLE, it turns into T-Rex. So that's an example of what the checkpoint looks like if it's working correctly. Let's walk through a little bit of pseudocode, a little bit of concepts to help us tackle this problem. So number 1, you're probably going to notice it looks an awful lot like checkpoint 1. And you're going to be able to reuse, hopefully, the work you did in checkpoint 1 in checkpoint 2. That's the first thing I would say. The second thing is all the things we talked about in the previous video are all still true. I recommend having a user input loop to get commands from a user. You probably want a process command method that takes the input from the user, processes that command. We know that the first token is what's going to determine the type of encryption or decryption we work with. That's going to be true the whole way through this project. And we're going to have everything is going to be upper cases, no punctuation. We're ignoring spaces. The same trick that you may have used in checkpoint 1 by using Unicode, by Unicode, of course, I mean the ASCII table, that same trick is going to work here. And the idea is if I have the char A, that can be converted to an int by using an explicit casting, and it'll turn into the number 65. I can explicitly cast a B to an int and get a 66. I can take a number, cast it to a char, and it goes back to being a letter. So if I need to shift by a certain amount, what I could do is pull out the individual char, convert it to an int, add the amount of my shift, and then return it back to being a char. That's one of the easiest ways to do it. We do have to be careful if we're encrypting and we go above the alphabet, or we're decrypting and we go below. Those are checks we have to make after we've changed things to an int, or after we've applied the shift. But other than that, hopefully that'll get it done for you. These are all the same pseudo code that we used for checkpoint 1. I'm going to recommend the exact same technique, but now wherever you've got a +1 in your code, you can use maybe plus the name of a variable. You might call it shift, something like that. And the idea is when you're given the command now, you'll have to say if it starts with over C, then you know it's probably advanced, whereas if it was equals over C, you know it's the basic cipher. So anyways, those are my hints on checkpoint 2, which is the Advanced Caesar Cipher for the Enigma project. Thanks for watching.